Hello class, welcome to lesson 9-7, which is all about growth and decay. By the end of this lesson, you should be able to solve problems involving exponential growth, and you should be able to solve problems involving exponential decay. So let's talk about what the equation for exponential growth looks like. Our equation, just because there's a lot of writing in the box, is y equals a times the quantity of 1 plus r. Okay? You want to make sure that you have this equation written down somewhere that you can easily reference because you're going to be using it a lot. Now let's talk about what each variable means. Y is going to be your final amount, kind of like your total, okay? A is going to represent your initial amount, however much you start with, okay? So Y is final amount, A is how much you start with. R is the rate of change expressed as a decimal, okay? So R is the rate of change expressed as a decimal. And then T represents time. Okay, T is time. So let's apply a real-world application to this problem so that way we can understand what exactly exponential growth means. Okay, so in 2008, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. We want to write an equation to represent the population of Flat Creek since 2008. Okay, so remember, our equation is y equals a times the quantity of 1 plus r to the tth power. Okay? So we want to write an equation for this first step. So I'm going to say y equals, and then a is our initial amount. In this case, that's going to be our 280,000 people. That is our initial population, okay? Times, and then remember we do 1 plus, what is our rate of change? In this instance, 0.85%. What we have to do is you have to take that and you have to make it, I know it's already a decimal, so that's a little bit confusing, but you want to take that and make it a regular number. Instead of percentage, we need to move it over 2 decimal points, okay? So we're going to say plus 0.0085. Just like if I gave you 25%, you would say that is 0.25. We're doing that same thing here. I said we had 0.85, so that becomes 0.0085. And then we have T represents our time since 2008. Because in this equation, I didn't say specifically like we're talking 2017. No, I just said in general I want an equation that I could use. So this is how I would write my equation. And then, according to the equation, what will the population of Flat Creek be in the year 2018? Okay, so then you're going to take your calculator and you're going to plug this in. So this is another one of those things that you want to be really careful as you plug into your calculators. One way you can do it is you can hit 280,000. You can type that in. And then if you use some parentheses, you always have 1 plus a decimal. So I'm just going to say 1.0085. And then I'm going to use the caret key. After I hit the caret key, I am going to put 10 in for my power. So I do 2018 minus 2008, and I get 10. Then once I've typed it into my calculator like that, I should get 304,731 people. Remember, if you ever get a decimal, when you have a problem talking about population, you need to round to the nearest person. Okay, why don't you go ahead and try this problem on your own? Good luck. Hopefully you said the equation you got was y equals 4,500 times the quantity of 1.0015 to the tth power. Now try to figure out what the population would be 2014. Hopefully you got about 4,540 students. If not, be sure to reach out for some help. I'm more than happy to help you. Okay, so we talked about exponential growth. Now we're going to talk briefly about compound interest. And our compound interest equation, again, I'm going to rewrite it just down below so that way you can see just what the equation is. These are all equations you are going to have to memorize, okay? So make sure you're taking note. Okay, so A represents whatever your current amount is. So compound interest, most often we're going to talk about investments. We're going to talk about saving money. And A is going to represent however much is in your bank account at that moment. P is going to represent however much money you initially had, however much money you invested the first time. Okay, so if you invested $500, you'd say 500 represents the principal amount. Again, you just have a 1 plus R represents the same thing that it did last time. It's your rate in a decimal. Okay. T still represents time. This is specifically time in years, though. Okay. Sometimes they'll trick you and they'll say like 6 months, so you have to change T to 1/2. Okay. Or if they say quarterly, then you're going to do 1/4. But just be careful as you read. N represents the number of times interest is compounded in years, okay? So that's the, like, if it says quarterly, it's going to be 4. So quarterly is going to be 4, and that represents N. T, sorry, when I said that, I should have said, if they ask you after like 6 months, how much do you have, you would put 1/2 in there. Or if they asked after 3 months, how much would you have in there, you would do 1/4 for T. Okay, so T's time in years, N's the number of times it's compounded. R represents our rate again. P is the principal amount. A is how much money you have currently. Let's try a problem. Okay, so we have, when Alice was born, her grandparents invested $1,000 in a fixed rate savings account at a rate of 7%, compounded annually. Alice will receive the money when she turns 18 to help with her college expenses. What amount of money will Alice receive from the investment? Okay, so remember our equation is A equals P times 1 plus R over N times NT, or to the NT power. Okay, so if we fill this out, we have A. We want to know how much money she'll have. Our P value, remember, is our principal amount. Her grandparents invested $1,000 for her. We always have that 1 plus. Then R, remember, we have 7%. We want it as a decimal, so it's going to become 0.07 divided by N is how many times it's compounded each year. Annually means 1 time per year. And then we have 1 times, and then after how many years are we checking to see how much it is? We're checking 18 years later. So that's how you'd set up this problem. Then if we plug it into our calculator, we'd have 1,000 times, in this instance, 1.07 to the 18th. Okay? So I recommend putting extra set of parentheses around the power, but you can type it into your calculator just like this, and you should get about $3,380. Okay. Let's quickly talk about some of the phrasing, just in case you don't know. Annually means one time per year. Biannually or semi-annually is 2 times per year. Quarterly is 4 times per year. Okay? So those are some of the most common phrases that you will encounter, okay? Go ahead and solve this one on your own. Good luck. Hopefully you decided that they would get about $4,682 from her investment. If you have questions, please be sure to ask. All right, let's take a look at our last problem for the day. Okay, so this equation, super similar to the first one we learned. The first one we learned was exponential growth. Now we're just talking decay. The only thing that changes is the fact that instead of adding, we are subtracting. Okay? Instead of adding, we are subtracting. Everything represents the same thing. Y is your final amount. A is the initial amount you had. And then you do 1 minus the rate to the tth power. Okay, so example 3. During an economic recession, a charitable organization found that its donations dropped by 1.1% per year. Before the recession, its donations were $390,000. Write an equation to represent the charity's donations since the beginning of the recession. Okay, so we have our equation. Remember, you need to memorize these. Let's fill in the information we know. So before the recession, donations were $390,000, a rate of 1.1%. So our equation is going to be y equals 390,000 times 1 minus, then we need to convert that 1.1 to a decimal. So 1 minus 0.11, 0.011, sorry, to the tth power. If you ever want to simplify that inside the parentheses, that is totally fine. I would be happy with that. And then you want to plug that into your calculator, just like I've been showing you. And when you do that, we want to estimate the amount of donations 5 years after the start of the recession. You just have to plug 5 in for t. And once you've plugged 5 in for t, you should get about $369,017 would be the amount of donations 5 years after the start of the recession. Okay? Go ahead and try this problem on your own. Hopefully you said the equation was y equals 24,000 times the quantity of 0.975 to the tth power. Go ahead and figure out the value of clothing donations 3 years after the start of the downturn. Hopefully you said approximately $22,245. Okay? If you have any questions, please be sure to ask. Make sure you have those equations written down somewhere in your notes, somewhere that you can easily see while you work on your homework assignment. Remember, you need to have them memorized, okay? Have a fantastic day.